This is the first video in a series of 2 that addresses reasoning with percents. In part 1, we will be finding the percent of a quantity. In the next video, part 2, we will be finding the whole when given the part and percent. This video addresses North Carolina Math Standard 6 RP4. Use ratio reasoning to solve real-world and mathematical problems with percents by using equivalent ratios such as benchmark percents to determine a part of any given quantity. This standard is the first time that students will be exposed to percents. The focus of this video is on introducing benchmark percents and teaching students how to use these percents to calculate the percent of a number when given the whole amount. When working with percents, students should apply skills learned in the other ratio standards to percents. It is for this reason rules and formulaic approaches should be avoided. One of the strategies suggested for the ratio standards is a double number line, which can also be used when introducing percents. By using a double number line, students can develop a conceptual understanding of benchmark percents and see both the multiplicative and additive relationships that exist with percents. Let's begin with the problem. If a cell phone battery lasts 300 minutes when it is fully charged, how long will the phone last once it is at 50%? We can begin to solve this problem by drawing a double number line. Label one number line percent and the other number line minutes. We can then place 0% and 100% on the percent number line. If the cell phone battery is at 0%, then you can use the phone for 0 minutes. We can place 0 on the minutes number line directly under 0%. If the phone is 100% charged, then it can be used for 300 minutes. We can place 300 minutes on the minute number line directly under the 100%. Since the problem is asking for 50%, we need to place 50% on the percent number line. Since 50 is halfway between 0 and 100, 50% should be halfway between 0% and 100%. If I now look for a multiplication or division pattern, I see that I can divide 100% by 2 to get to 50%. So to find 50% of 300 minutes, I need to divide 300 by 2, which gives us 150 minutes. Therefore, 50% of 300 is 150. You can now ask students to find other percents. Some students may say you can find 25% by dividing 50% by 2 and then dividing 150 minutes by 2 to get 75 minutes. You may want to ask students if there's another way to get to 25% to see if someone recognizes that you can divide 100% by 4 and then divide 300 minutes by 4. Let's look at another problem. If a cell phone battery lasts 240 minutes when it is fully charged, how long will the phone last once it is at 10%? Once our number lines are labeled, we can place 0%, 100%, and the correlating number of minutes on the number line. Since the problem is asking for 10%, we need to place 10% on the number line. If I now look for a multiplication or division pattern, I see that I can divide 100% by 10 to get to 10%. So to find 10% of 240, I need to divide 240 by 10, which gives us 24 minutes. Therefore, 10% of 240 is 24. You can now ask students to find 20%. Some students may say you can find 20% by multiplying 10% by 2 and then multiplying 24 minutes by 2 to get 48 minutes. You may want to ask students if there is another way to get to 20% to see if someone recognizes that you can divide 100% by 5 and then divide 240 minutes by 5. Let's take a look at one more problem. If a cell phone battery lasts 450 minutes when it is fully charged, how long will the phone last once it is at 70%? Once our number lines are labeled, we can place 0%, 100%, and the correlating number of minutes on the number line. Since the problem is asking for 70%, we need to place 70% on the number line. If I now look for a multiplication or division pattern, I see that there isn't a whole number I can divide by to get from 100% to 70%. However, since 10 is a factor of both 100 and 70, I can use 10% to help me find 70%. To find 10% of 450, I need to divide 450 by 10, which gives us 45 minutes. 10% of 450 is 45. To find 70%, I now need to multiply 10% by 7 to get to 70%, and then multiply 45 minutes by 7 to get to 315 minutes. 70% of 450 is 315. Let's look at our last problem. If a cell phone battery lasts 360 minutes when it is fully charged, how long will the phone last once it is at 75%? Once our number lines are labeled, we can place 0%, 75%, 100%, and the correlating number of minutes on the number line. If I now look for a multiplication or division pattern, I see that there isn't a whole number I can divide by to get from 100% to 75%. Ask students what factor of 175 we can use to help us find 75%. Some students may suggest 25% and others may say 5%. Since both 25 and 5 are factors of 75 and 100, we can use either of these percents to help us find 75%. Let's use 25% first. When looking for a pattern, I see that I can get to 25% by dividing 100% by 4. To find 25% of 360, I need to divide 360 by 4, which gives us 90 minutes. 25% of 360 is 90. To find 75%, I now need to multiply 25% by 3 to get to 75%, and then multiply 90 minutes by 3 to get to 270 minutes. Remember, students may want to use 5% as the common factor. To find 5% of 360, I need to divide 100% by 20 and then divide 360 by 20. 5% of 360 is 18. To find 75%, I now need to multiply 5% by 15 and then multiply 18 by 15 to get 270. 75% of 360 is 270. Some students may suggest that 1 is also a common factor of both 100 and 75. Encourage the use of 1 as a common factor. Once students realize they can always use 1, they can now find any percent of a quantity, including percents like 27%, 53%, and 74%. As illustrated in this video, 6 RP4 calls for students to use benchmark percents to determine the part of a given quantity. By using a double number line, students connect ratio reasoning to the percent unit. In 6th grade, students began exploring percents for the first time using ratio knowledge that builds on pattern relationships from elementary grades. Students will use their knowledge of percents, including benchmark percents, in 7th grade when they expand their understanding of percents to percents involving decimals and fractions and explore more complex percent problems. In 7th grade, students will also apply percents to interpret circle graphs.